Okay, so 4.6, solving logs and exponential equations. Um, these are a little bit longer of notes, so just kind of be ready for that, okay? I would suggest, as you're doing it, to just do each step like even before you see it, all right? So what we're going to do is we're going to use properties, same bases, we're going to log both sides, do all that kind of thing. I'm going to not tell you what to do, but what you can do, and this is one way that you can do it, all right? So I would say you want to write that down, and you're solving log base 3 of 243 equals 2x plus 1. So what would you do first? Go ahead and do it and see if it's something like this. So you might get, eventually, whatever you do, you're going to get 5 equals 2x plus 1. And then you're just solving for x, and x equals 2. All right, how would you check that? You can literally plug it in, and you would get 5 over here, and this is equal to 5 because 3 to the 5th power is 243. Can you do 3 to the power of this equals 243? You can, but that doesn't help you because we want to keep that x right where it is. It's not a power right now, so what we want to do instead is simplify the left side, okay? What you're always trying to do is get that x down if it's a power. That's the goal. And if it's not a power, like here, then you just, keep it there and do something else to the left side. All right, so number 1b, let's say something like this. See how the x is up here? So now we have to somehow bring it down. So what are you going to do to both sides? Maybe ln both sides. And then you get something like, I just wrote it all together. So then you get something like this, and then you solve for x, and then you get that answer if you are not putting it in your calculator. So this is a no calculator answer, okay? So it's the setup, and then if you put it in your calculator, you get some sort of decimal, and I don't remember what the book wants you to do when you're doing your homework, so it just depends. This is our fractional answer, and then decimal you would put into your calculator. All right, something like this. See how the x is already in the right place, but then this is a log, so we want to change it somehow so it's not a log anymore. You can't do anything with that left side, right? Like we did over here. You can't do anything with the left side, so instead maybe 3 to the power of 2, or you can do 3 to the power, 3 to the power, and you get something like this. And then now you can go ahead and just solve for x. Be very careful, x is plus or minus 2 root 2. So if you have x squared, when you take the square root, you get a plus or minus, okay? It's not just 2 root 2. Because if you plug in a negative, you square it, plus 1, it's still a positive. So you can't have a negative or 0 here. You can't have a negative or 0 here. But your answer for x could be negative if you plug it in and end up getting a positive, all right? So just be careful of that. Right here, something like this. What are you going to do first? Do not do 5 to the power first. You have to make it a log all by itself. So move that 2. And then now you can do x squared equals 9, x equals plus or minus 3. But if we plug in a negative 3, notice I'm checking it. So if you plug in a negative 3, that wouldn't work because you cannot have a negative here. So it's just positive 3. So this one was plus or minus. This one is just the positive version. So just kind of be careful about stuff like that. Okay, something like this. So what can you do right here? Well, maybe combine those logs, right? So go ahead and combine the logs, multiply them together. And then 4 to the power of 1 equals. And then keep going until everything equals 0. Factor. And you have 2 answers. Can you plug in a negative 2? Yes, 2 minus negative 2 is positive 4. Negative 2 plus 3 is positive 1. That's okay. A 1, is that okay? 2 minus 1 is positive. 1 plus 3 is positive. Yes, both of those answers are okay. All right, the next one. 5 to the power and 3 to the power. Okay, let's see. Well, I know the powers both have x's in them, so I got to get them down. So maybe log both sides or ln both sides. You can do anything to both sides, right? So I like to use ln. How come I use ln instead of log base? Because they're different bases anyway. And then also because ln literally is 2 letters and log is 3 letters, and I'd rather use 2 letters than 3 letters. So you can ln both sides and then bring that power down to the front. Make sure that you're using parentheses because you want to multiply in the ln's. Oh, let's try that. So multiplied them and distributed them. And then you're solving for x. So what are you going to do? Get the x's on one side. Get everything else on the other side. So this goes on the left. This goes on the right. Let's do that. All right. Now I have an x and an x. Let's factor out the x. Okay. I know there's a lot going on here, but you're just solving for x. Factor out the x, and then you're going to divide. So factor out the x, which is this step right here, right? And then divide. So you get 2, blah, 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 all over ln. Technically, this is ln of, what is this right here? Ln of 3 cubed. So ln of 27. So I can write it as ln of 5 over 27. Do I have to write it this way? No. Could I just put this under this? Yes. But if this is a multiple choice question, make sure that you choose this one as your answer. Okay. G, let's look at this. Okay. So this one, I got an x up here and an x down here. Okay, let's use the power rule. Let's bring that down, but make sure you're using parentheses. All right, how else can you write this? How about squared? All right, how do you get rid of a squared? Take the square root of both sides, but I don't remember why I wrote that. But you're gonna make sure that you have that equals plus or minus 2, because you are the one taking the square root, so you have a plus or minus 2. All right, so really it's 2 to the power of 2 and 2 to the power of negative 2. And what would that be? I'm going to cover this. That would be 4 and 1/4. And I said both work because the 4, if you plug it in, is okay. And also 1/4 is also positive, so if you plug in 1/4, that's okay as well. Okay, if you simplified with a 4 or with a 1/4, you would eventually get 4. I'm not going to do it with you right now, but it is true. Okay, so you get 2 answers for G. Okay, for H, let's say you have something like this. This is getting more and more interesting. For H, you have something like this. Okay, they have different bases. First step, let's try change of base. So I did change of base and I used the same basis I did. Instead of just log x over log 16, I did log base 2 of x over log base 2 of 16. Why did I choose the 2? Because, well, you'll see. But this one that I didn't change already has a log base 2. So if I do log base 2 of x over log base 2 of 4, what do these become? Well, what is log base 2 of 16? That's actually like something that you can simplify in your head, right? So really, this is a 4, and this is a 2 as a denominator. Okay, let's multiply everything by 4. So let's go ahead and clear those fractions, multiply everything by 4. So times 4, times 4, times 4, times 4. All right, I got 1 plus 2 plus 4 equals 7 of them. Divide by 7, and I get log base 2 of x equals 4. Oh, x equals 2 to the 4th power, which is 16. All right, if you plug that in, will it work? Absolutely, you can do it very quickly right now. 16 gives you 1, 16 gives you 2, plug in the 16 gives you 4. 1 plus 2 plus 4 is 7. So if you plug it in, it will work afterwards. Okay, there's a back. Remember what I said about there's more. Okay. Okay, it gets a little bit more interesting now. It says using substitution. All right. So using substitution, let's say something like this. So remember when we used substitution and we had powers, not powers, sorry. And we had something like, cosine squared and cosine. It's that same idea. So let's think of this as this, right? So this right here, that's going to be just 2 to the x, but isn't this the same as 2 squared to the x power? And when you write that, isn't that 2 to the 2x? Okay, notice this is something squared, and then this is just that something, and then we have a number over here. So using substitution is like, okay, let's replace this with a letter, and then this is going to be a squared, and then this is just your negative 12. Okay, this is factorable. In your head, you can factor this. So that one, when you factor, you get a equals 4 and negative 3. Is that your final answer? Are you solving for a? No, you're solving for x. So what is a? A is 2 to the x power. Okay, so 2 to the x power equals 4. That's this one. That would mean that x would have to equal 2. All right, how about this? 2 to the x power equals -3. Can that be done? What would x be? No, you can't do that. You can't make a 2 into a -3 using powers. So that doesn't give you an answer. The final answer is just x equals 2. So if you plugged in a 2 and you plugged in a 2, you would get, I don't know what you would get. You would get something minus 12 equals 0, which means this whole thing would equal 12 eventually. Okay? Let's see. Okay. Let's try another. So this one looks a little bit different. Be careful. Okay, how would you have to mess with this actually. Okay, so this one is definitely trickier. 3 to the x plus 1 power. Okay, what does this look like if you have the same bases but being multiplied? Wouldn't that basically be 3 to the x times 3 to the first power? Aren't these equivalent? And what's nice about this is that you can really see that now it's just 3 times something, and then this is just that something squared, and then here's my -4. Can you factor this? Absolutely you can. You can factor that in your head. You get a equals -4, a equals 1. Okay, but what does a equal? A equals 3 to the x power. So we're going to start with that first one, the -4. 3 to the x equals -4. Doesn't work. We can't do that. X does not exist. Okay, what about the 1? 3 to the x equals 1. Oh, x would have to be 0. Okay, so that's our only answer. So if this was a 0 and a 0, you would get 1 plus 3 minus 4 equals, yeah, 1 plus 3 is 4. 4 minus 0 is, or 4 minus 4 is 0. There you go. Okay, one more of those, and then one more after that, okay? So something like this. All right, how do you do this? What would that look like? What would the 2 to the power of 2x multiply with to get really that -1 as a power? Wouldn't it be that? Right? Because if you have the same bases and you multiply, you can add the powers. So wouldn't it have to be this? What's nice about this is that it can be rewritten. That's a 1/2 in front of my a squared. Right, so here's my 1/2, here's my a squared, here's my a, so a squared, a, and then my -4. Okay, this one, I would multiply everything by 2 before I factor, and you will always be able to factor, okay? So you factor, solve for -4 and 2, plug it back in. What does a equal? A equals 2 to the x power. All right. So if 2 to the x equals -4, nothing. If 2 to the x equals 2, you get x equals 1. Okay, you get one answer, x equals 1. There you go. So there's substitution. Here's one last one. This one says verify or show. So when you verify or show, you start with something, and then you get to the other side. So let me see if I wrote this correctly. I did not. Okay, so something like this, but I did not. Okay, I'm gonna fix this as we talk about it, okay? So how do we prove things in pre-calculus, okay? You start with one side, the harder side. Obviously, this is the harder side. You put an equal sign, and then you only work on the other side, and you stop working on the first side. So the left should be this, equals, and then equals, and then finally we should end up with 0. So I'm going to rewrite this as I show you, okay? So I think I said over here, you can only work on one side. That is true. So after you start, you can only work with one side. So I would start by rewriting, actually, so I didn't do that. You need to, I'm gonna write it in, and you need to actually do it. So your first step is to rewrite right here, rewrite the OG original harder side. I'll say it like that, okay? So first you're gonna rewrite that OG harder side. So this gets rewritten, and then there's an equal sign, and then the next step is this step. So this is step 2. Step 1 is to rewrite. Step 2 is to do this, because we can go ahead and start condensing, so you're multiplying. And then I would have an equals over here. And then the next step is me actually doing the multiplication. So if you have a plus b times a minus b, don't you get a squared minus b squared? So this is a squared minus b squared. I'm going to put an equal sign. So first step was to rewrite, and then this is the second step, this is the third step, and then go ahead and square them, and you get this, correct? Equals. And then go ahead and start subtracting, or you can, distribute that negative, and you get this. If you distribute the negative, I still have my equals. So this is technically the right side. The left side was just this, and it had an equal sign, and then equals, 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 equals. We're only working on the right side. And then subtract the x's, you get log of 1. And what is log of 1? Log base 10 of 1, log base anything of 1 is 0. And I'm so happy about that. I'm going to box it and put a happy face. Yay! Okay, so something like that. I did this. Don't do that. I'm going to wipe that out, okay? Don't do that. So this was many years ago, but we don't do that. Get rid of it all. See, all gone. So you can only work on one side, and it would be the right side after you rewrite the harder side. So I am missing one step, and then everything else goes on the right side, and eventually we want this as our final answer. All right? Okay, so there are your notes for the last section of chapter 4. Good luck, good luck.